In this lecture, we are going to discuss about a Bohr atomic model. Dear student, Bohr atomic model is one of the important topic in physics. If you want to understand how the atomic structure developed over a period of time, it is very important to understand a Bohr atomic model. Before the Bohr atomic model, there were different atomic models produced to explain the structure of atom. And in order to understand the Bohr atomic model, you need to understand the pre-existing models about the structures of atom. Dear student, it was a Greek philosopher known as Democritus who proposed his first theory about the matter. And this theory is known as Democritus' atomic theory. Democritus was a Greek philosopher. He was not a physicist. And he proposed that matter is made up of a small particles, and the smallest particle of a matter is known as atoms or atom. Atom is derived from a Greek word atomus, which means undivisible or uncuttable. So according to Democritus, matter is made up of small particle, and the smallest particle of matter is known as atomus, which is undivisible or uncuttable. At the same time, there was another philosopher known as Aristotle. Aristotle proposed his own theory about matter. And according to the philosophy of Aristotle, matter is made up of four elements, and these elements are air, water, fire, and ether. Since you know that in that era, Aristotle was more popular than Democritus, so people mostly believe about the idea of Aristotle rather than the theory of Democritus. However, the theory of Democritus was basically a step foot toward the understanding of a structure of an atom. He was the first person who introduced the word atom for a particle of a matter. So after Democritus and Aristotle, there was another scientist which was basically a British chemist known as John Dalton, and he proposed his own atomic theory about the matter, which is known as Dalton atomic theory. According to Dalton, smallest particle of matter is known as atom. Atom is present in a different shapes and sizes, and as well as there are hooks and holes present in an atom. So these hooks and holes in an atom, hooks and holes in an atom combines, and due to which we see a macroscopic or observable material. Macroscopic material. So dear student, basically Dalton validated Democritus' atomic theory that smallest particle of a matter is atom, and atom is present in a different form, in a different shape and different sizes, and they have a hook and hole in them, and the hook and hole basically of an atom combines and they form a macroscopic organism. Till that, people believe that smallest particle of a matter is known as an atom. However, it was J.J. Thomson who discovered electron in his famous cathode ray tube experiment. And J.J. Thomson proposed that on the discovery of electron, J.J. Thomson proposed his own model, which is known as Thomson plum pudding model. And according to Thomson plum pudding model, atom is not the smallest particle of matter, but there are also another small particle present in an atom, and these particles are negatively charged particles known as electrons. Atoms have a positive charge which is uniformly distributed, and in that positive charge, electrons are negatively charged electrons are embedded inside it. So this is called plum pudding model. Now, the student, after plum pudding model, there was J.J. Rutherford performed his famous gold file experiment, and on the basis of gold file experiment, Rutherford proposed his own atomic model. And according to Rutherford, matter an atom is mostly an empty space, and electrons are not embedded in a matter, but electrons are present somewhere in empty space. The center of an atom is consists of a positively charged, and the center of an atom is known as nucleus, and the positive charges are basically concentrated toward the nucleus of an atom. So according to Rutherford gold file experiment, Rutherford proposed his atomic model, and according to that model, atom is basically have electron, and these electrons are not embedded in a nucleus, but they are present around the nucleus, and nucleus have a positively charged, and these positive charge are concentrated toward the center of atom or toward the nucleus. So now, the student, the main question here arises is that electrons are present in empty space near the nucleus of an atom. Then why electrons? You know that electrons have negative charge and nucleus have a positive charge. So positive charge will basically attract negative charge. Then how and why structure of an atom remain stable? So this question was basically answered by Bohr by introducing his one of the most popular atomic model known as Bohr's atomic model. Bohr's atomic model. The student Bohr was a first scientist who introduced the concept of quantization of an atom. He introduced the concept of orbital and shell in an atom, and on the basis of that, he proposed his own atomic model. He gave postulates, and on the basis of that, he concluded that by a structure of an atom remain stable. So basically, this was the brief history of the atomic model present before the Bohr atomic model. This was just an overview. So now, dear student, let us discuss about the key postulates of Bohr's atomic model. So now let us discuss about the postulates of Bohr atomic model. The first postulate of Bohr atomic model is that atom has a center and the center of atom is known as nucleus. Before the Bohr atomic model, it was believed that such as before the Bohr atomic model, uh, Democritus and Dalton, Democritus and Dalton said that smallest particle of matter is known as atom. However, after the discovery of electron by Thomson, Thomson said that Thomson said matter is made up of atoms and atoms are also consist of other small particles, and these small particles are negatively charged, and these are known as electrons. So after the Thomson atomic model, which is basically known as Thomson plum pudding model, it was Rutherford who said that Rutherford who said that atom consists of an empty space, and in empty space there are electron presence, and there is a nucleus in in an atom, and positive charge are concentrated toward the nucleus of atom. So basically, the first postulate of Bohr atomic model, we state that has a center. Atom has a center, and center of an atom is known as nucleus, is basically a validation of Rutherford atomic model or Rutherford atomic theory. So this was first postulate of Bohr, that any atom have a center, and the center of an atom is known as nucleus. Bohr proposed his second postulate on the basis of Rutherford Goldfile experiment. In Rutherford Goldfile experiment, Rutherford incidented highly radioactive alpha particles on a gold file, and he observed that most of the alpha particle passes through the gold file and they reach the fluorescent screen without deflection. There were very few alpha particles which were deflected backward backward, and however mostly alpha particle passes through the gold file without deflection. So on the basis of that experimental observation, Rutherford said that most of the space of an atom is empty, and it consists of electrons, but they are somewhere in the around the space of an atom, and most of the space of atom is empty, and the center of atom consists of positively denser, positively charged particles which is known as nucleus. So now question here was that if electrons are present around the nucleus of an atom, nucleus has a positive charge, electron have a negative charge, then the electron around an atom must fall into a nucleus of an atom due to a force of attraction. Then why structure of an atom remain stable? So this question was answered by by Bohr by proposing his second postulate. So now let us discuss second postulate of atomic. Bohr's second postulate states that electrons revolve around a nucleus in a fixed circular paths. And these fixed circular paths are known as orbit or shelf. And in these orbit or shelf, electrons have fixed energy and velocity. So, this second postulate is known as a concept of quantization, which was introduced by a Bohr. So according to second postulate, electrons are present in a nucleus, around a nucleus, but these electrons are present in a fixed energy level. And these energy levels are known as shells or orbits. So according to Bohr, every atom have a shell or orbits, and electrons are present in these shells and orbits, and every shell and orbit have a specific energy and as well as velocity for electron. So this condition is basically introduce a concept of quantization. The word quantization means fixed. So according to Bohr, electrons are revolve around a nucleus in a fixed energy level, and these energy levels are known as shells or orbit. And every shell or orbit orbit have fixed have fixed energy. So electron revolving in a shell or orbit have fixed energy, and as well as as well as as well as fixed velocity. So dear student, this is called a concept of quantization. Rutherford did not give the concept of quantization. According to Rutherford, electrons were present anywhere, anywhere anywhere around nucleus. However, according to Bohr, electrons are present in in orbit, and the energy of orbit or shell is basically it is fixed, and that is the reason electron basically remove or revolve in a fixed path give longer life to atom, and that is the reason due to which atom remain stable for longer time. So now dear student, let us discuss second postulate of Bohr on the basis of an example of a sodium atom. So dear student, according to Bohr, atom consists of a nucleus. Consider that this is a nucleus of an atom, a nucleus of a sodium atom. Since you know that the atomic weight of or atomic mass of a sodium is 23, and sodium has basically 11 protons, and nucleus of sodium have 11 protons and as well as 12 neutrons. So the number of electron plus proton make an atomic mass or atomic weight. So the atomic weight of a sodium atom is 23. Every atom have energy levels around it, and these energy levels are known as shells. First energy level around a nucleus of an atom is known as K shell. Second energy level around a nucleus of an atom is known as L shell. Whereas third energy level around a nucleus of an atom is known as M shell. So here we are discussing sodium atom. So sodium atoms have only 11 electrons, and these electrons are usually accommodated in first three shells. So for larger atoms, the number of shells, basically for bigger atoms, number of shells basically increases, and these shells accommodate electrons. So the student, in first shell there are two electrons. Basically this red circular ball type thing represent an electron, whereas the second shell, which is known as L shell of sodium atom, it accommodate 8 electron, and third and last shell of sodium atom, which is known as M shell, it accommodate 1 electron. So dear student, now this is very important point to note that according to Bohr, electrons are present around an atom, around a nucleus in an atom, in a fixed energy levels are shells. So each these shell, this K shell, L shell, and M shell, each these shell have a specific value of energy. Okay, the inner shell, which is known as K shell or ground shell, have lesser energy than the higher shell L shell, and similarly L shell have lesser energy than the exterior M shell. So every shell K, L, M, and so on in an atom have a specific energy. So these electrons which are present in K shell will have different energy than the electron present in M shell, and similarly electron present in L shell will have different energy than the electron present in M shell. So electron which is present closer to the nucleus in a K shell or ground shell have lesser energy than the electron present in L shell, and similarly electron in L shell will have lesser energy than electron present at M shell. So higher is the energy level or higher is the shell, higher will be the energy of electron. However, the energy of electron in K, L, and M shell will be fixed. Any electron which is present in K shell, like these two electrons will have same fixed energy. Similarly, electron present in L shell, these 8 electrons, every of these 8 electrons will have same and fixed energy. Usually, the energy of electron is in K shell is around minus 13.6 electron volt, and similarly, this is slightly more like around 5 around 1.5, around 3.5 electron volt or something. So the minus 3.5 electron volt something. So basically K shell electron will have lesser energy than the L shell electron, and similarly M shell electron will have higher energy than the K shell electron. This means that electron present in K shell will have lesser energy than the electron present in L shell, and electron present in L shell will have lesser energy than the electron present in M shell. But energy of electron in all these K, L, and M shell will be fixed. So this basically give us about the concept of quantization, which mean that electron and an atom around a nucleus will always have a fixed energy, and due to fixed energy, electron, the structure of an atom basically will remain stable, and electron will never fall into a nucleus. Now, the third postulate of Bohr atomic model states that electron can revolve in a shell or orbit if their angular momentum is integral multiple of h divided by 2 pi. So this third postulate of Bohr atomic model is known as condition of quantization. In second postulate, Bohr said that electrons revolve around a nucleus in a fixed energy level or shell. This postulate is known as a concept of quantization, or it gives concept about the quantization of energy. But question here is that what will be a condition of quantization? What will be condition for electrons to remain in energy levels around a nucleus of an atom in a shell? So the condition of quantization was basically given by Bohr in third postulate that electron will remain in orbit or in a shell in an atom if their angular momentum is in integral multiple of h divided by 2 pi. So consider again example of a sodium atom. Sodium atom has a nucleus having 11 proton and 12 neutron, and around the nucleus there are energy level K, L, and M, and 2 electrons are present in first energy level, 8 electrons are present in second energy level, and 1 electron is present in third energy level or in M shell. So all these electrons in their energy levels have fixed energy. Apart from energy, the electron presence in K, L, and M energy levels have a fixed angular momentum. Such as electron in K shell, you know that there are 2 electrons in a K shell. So these 2 electrons will always have fixed angular momentum. Similarly, electron in L shell, there are 8 electrons in L shell. So these 8 electrons will always have fixed quantized angular momentum. Similarly, there is 1 electron in M shell. So this electron will also have a fixed angular momentum. So now, according to the condition, or according to the postulate of uh, Bohr, electron in any energy level have a fixed angular momentum, and angular momentum of electron is equal to nh divided by 2 pi. H is basically known as Planck constant, and n basically represent a number of n is number of integer which represent number of energy levels, and number of energy levels are 1, 2, 3, 4, 5, and so on around an atom. So on the basis of this condition, we can calculate angular momentum of electron in each energy level. Suppose that we want to calculate angular momentum of electron in first energy level or K shell. We can calculate this from this equation. Since you know that according to Rutherford, angular momentum of electron in energy level is equal to L is equal to NH divided by 2 pi. So in first energy level N will be equal to 1. So angular momentum of electron in first energy level or L shell will be H divided by 2 pi. And as you know that the value of H, which is basically a Planck constant, and value of H is 6.65 into 10 raised to power minus 34 joule second, and value of pi is 3.14. So by incorporating of these mathematical values, so in this way we can basically calculate the angular momentum of electrons in any energy level. Suppose we want to calculate angular momentum of electron in second energy level or second shell. Since you know that condition for angular momentum of electron in second energy level is equal to L is equal to NH divided by 2 pi. So in second shell, value of n will be 2, and value of h is known, which is 6.62 into 10 to the power minus 6.65 into 10 to the power minus 34. And similarly, value of 2 pi is 3.14. So by doing a mathematical calculation, we can basically calculate angular momentum at of electron in a second orbit or in a second shell. So in this way, we basically calculate angular momentum of electron in any energy level, like first energy level, second energy level, third energy level, fourth energy level, and so on in an atom. So this is basically, it is a condition of a quantization uh, which states that electron revolve around a nucleus, but the electron will have a specific angular momentum in its orbit or shell, and they will always revolve in orbit or a shell with a specific angular momentum. Dear student, please keep in mind that integer n, which basically represent shell or which represent shell or orbit in an atom, it could never be half and or it could never be 3 by 2 or 5 by 2. And that is the reason that you will always, the energy of electron in an atom will always be discrete in a shell, and you will never find their energy as constant. And that is the basic reason for the stability of atom due to a stability of electron in energy levels or in a shell. So the student, fourth postulate of Bohr atomic model state that electrons revolve around a nucleus in a shell. And in a shell, the electrostatic force between electron and a nucleus will produce a centripetal force. So if I simplify this fourth postulate of Bohr atomic model, it's basically state that electrons are present in energy levels in an atom. And these electrons are negatively charged particles. And nucleus has a positive charge, or it has a proton. So there will be an electrostatic force of attraction between electron, which is negatively charged, and proton, which is positively charged. So this electrostatic force of attraction will compel electron in a shell to move in a circular path around a nucleus. So electron will observe a centripetal force. Centripetal force is a force which compel a body, which compel a particle to move in a circular path. And as you know that according to Coulomb's law, a force of attraction between two oppositely charged particles, a force of electrostatic force between two opposite charged particles is equal to 1 over 4 pi epsilon naught into q1 q2 divided by r square. This is known as Coulomb's equation or Coulomb equation for electrostatic force. Now, Q1 is an electron, whereas Q2 is a charge on a nucleus, which is equal to Ze. Z represent atomic number and E basically represent a positive charge. So electrostatic force caused by electron and proton of nucleus will be equal to Fe will be equal to 1 over 4 pi epsilon naught E into Z E divided by R square, and equation will become electrostatic force will become Fe is equal to 1 over 4 pi epsilon naught Z E square divided by R square. And now, dear student, according to fourth postulate of Bohr, it states that electrostatic force between a positive charge nucleus and negative charge electron cause a centripetal force which basically compel electron to move in a circular path in an orbit. So electrostatic force Fe will be equal to centripetal force. And as you know that centripetal force is a force which compel a body to move in a circular path is equal to mv square divided by r. M is a mass of electron, v is a velocity of electron, velocity with which electron move in an orbit or shell in an atom, and r is basically a radius of a shell. So now suppose this is equation number 1, so we will put the value of electrostatic force and as well as the value of centripetal force in equation 1. So we will get, as you know that electrostatic force is 1 over 4 pi epsilon naught, 1 over 4 pi epsilon naught into Z E square divided by R square will be equal to mv square divided by R. Let's say this is equation number 2. So we basically this postulate number 4, we can conclude postulate number 4 of Bohr atomic model that an electron revolves in a circular path in an orbit, and in orbit there is a force of attraction, electrostatic force of attraction between negatively charged electron and positively charged nucleus, and the electrostatic force of attraction basically cause a centripetal force. The electrostatic force of attraction between nucleus and electron is equal to a centripetal force, which result in a movement or motion of electron in a circular path around an atom. Dear student, the fifth postulate of Bohr atomic model state that while electron revolving in a particular orbit or a shell, they neither gain or lose energy. So this means that energy of electron in orbit or shell is fixed. Bohr called this as a condition of a quantization for electron in an orbit. And he basically called the energy levels as a stationary energy level. So this means that according to Bohr, Bohr said that every orbit in an atom has a fixed energy. Every orbit has a fixed energy. And electron in any orbit will have a fixed energy, fixed electron energy. So they will have same energy, as an energy of an orbit, So this means that the electron in an orbit will have fixed energy, which means that the orbits or shells will have shells will have fixed energy. And due to fixed energy of orbit or shell, Bohr called orbits or shell as stationary energy levels. And basically, he called them stationary energy level in order to suggest a condition of quantization of an atom. So on the basis of fifth postulate, we can say that K shell, L shell, M shell, N shell, and so on, every shell have their own fixed energy associated with them. And these shells are shells are stationary energy levels due to stationary energy levels due to fixed amount of energy So this is fifth postulate of Bohr atomic model, that electron basically remain in an energy levels, and every energy levels have fixed amount of energy. An electron must have same amount of energy as the amount of energy level, and due to this, electron will remain in that energy level for longer time, and due to this, the life of atom or stability of atom will remain. So student, before discussing uh, Bohr six postulates, let's do some calculations on the basis of first five Bohr postulates. So student, on the basis of five postulates of Bohr, we can do some calculation. Basically, on the basis of these postulates, we can calculate the radius of orbit or shells in which electrons are revolving. We can calculate velocity of an electron in orbit or shell. Velocity of electrons in orbit or shell. We can calculate kinetic energy of electrons. Similarly, we can calculate potential energy of electrons in an orbit. We can also calculate total energy of electrons in orbit or in shells. So now let us calculate radius of an orbit in a shell. So step by step we will do all these types of calculations. So you will basically understand a potential application of Bohr atomic model in an atom. Let me clean this first. Let's first do the calculation of radius of atom. Radius of orbit or shell of an atom. Since, according to the postulate of Bohr atomic model, atom has a nucleus and nucleus is positively charged and electrons are present around a nucleus in an energy level, and these energy levels are known as shells. The first energy level around the nucleus is known as K shell. So suppose that electron is present in a K shell of an atom. So there is, according to Bohr, there is force of attraction between positive and negative charge. There is a force of attraction between a nucleus which is positively charged and electron. So the electrostatic force between nucleus and positive charge electron is basically represented or calculated by uh, Coulomb force, and the magnitude of Coulomb or electrostatic force between a nucleus and electron is equal to 1/4 pi epsilon naught into uh, Q1 Q2 divided by R square. So this is formula for a Coulomb force. In case of we have electron, we have nucleus which is positive charge, and we have an electron which is negative charge. So the force of electrostatic force between electron and a nucleus will be F E is equal to 1/4 pi epsilon naught. Q1 is electron, so we will write it as E, and Q2 is a charge on a nucleus, which is equal to Z into E divided by R square. So this will be electrostatic force between electron and proton, or electron and a nucleus of an atom. So according to Bohr, the electrostatic force between electron and nucleus result into a centripetal motion or circular force Fc, and this centripetal force Fc is equal to the electrostatic force. Centripetal force F centripetal is equal to electrostatic force, which is the force between electron and a nucleus of an atom. So as we know that, let's say this is equation number 1. We know that centripetal force F centripetal is equal to mv square divided by r, which is a radius of an first orbit or K shell. And similarly, electrostatic force is let's say it as equation number 2, and say this as equation number A. So putting equation number 2 and A in equation number 1, we get basically mv square divided by r is equal to 1 over 4 pi epsilon naught into z e square divided by r. So let's say this as equation number 3. So according to Bohr, angular momentum of an electron in an orbit is quantized, and angular momentum, which is mvr, is equal to integral multiple of h divided by 2 pi. Let's say this is equation number 4. So square the equation number 4, squaring equation number 4, square equation number 4, we get m square v square r square is equal to n square h square divided by 4 into pi square. Suppose that this is equation number 5. Now, dear student, divide equation number 3. Dear student, sorry, divide equation number 5, this equation number 5 with equation number 3. So basically we get m square v square r square divided by m v square divided by r is equal to n square h square divided by 4 pi square divided by 1 over 4 pi epsilon naught 4 pi epsilon naught z e square divided by r square. So basically this m will cancel with this m square. Similarly, this 4 pi will cancel with 4 pi square. So basically we will get mr cube equal to n square h square epsilon naught r square divided by z e square pi into m. So r square will basically cancel with r cube, and we basically will get radius of an orbit r is equal to n square h square epsilon naught divided by z e square pi m. So now keep in mind that n represent number of integer or its integer, and it's represent a number of shells, could be 1 2 3 and so on. And basically in this equation number 6, n is basically represent an nth orbital or nth shell. So the radius of nth shell r will be equal to rn will be equal to n square h square epsilon naught divided by z square E charge on electron pi into mass of electron. This is a radius of nth orbit. So the radius of nth orbit Rn is equal to n square h square epsilon naught divided by z e square pi into m. So let's say this is equation number 5. So in case if we want to calculate a radius of first orbit, so this means that for first orbit radius will be equal n integer will be equal to 1. So the radius of first orbit will be r1 is equal to h square epsilon naught divided by z e square pi into m. So now, as you know that uh, h square epsilon naught divided by e square pi m, these are basically variables and they have fixed value. And their value is 0.53. Then our equation number 6 will become radius of a first orbit or a shell will be equal to 0.53 into n square divided by z m strong. Since n and z are variables, they basically vary for different types of atoms and as well as the number of basically atomic number basically vary for different atoms, and similarly the n is representing a number of orbitals. They are variable, their value may be changed, but the value of this h square epsilon naught divided by e square pi m is fixed. So basically their value is 0.53. So this means that radius assigned to an orbit of an atom is basically, or a shell of an atom is fixed. It depends on the number of orbit and as well as the atomic number of an atom. So similarly, we can calculate a radius of an atom, a radius of a second orbit R2 by putting the value of n as a 2 square divided by h square epsilon naught divided by z e square pi into m. So basically we can get radius of second orbit as 4 h square epsilon naught divided by z e square pi into m, which will be r2 will be equal to 0.53 into 4 divided by z, the atomic number of an atom, and a is the Armstrong. Its value will be in Armstrong. So this will be radius of an atom of this will be radius of second orbit or a shell. Similarly, we can calculate the radius of third orbit or a shell in an atom. It will be 0.53 multiplied by n square. Basically, it is third orbit, so it will be 9. So we get 9 divided by z into Armstrong. So this will be a radius of a third orbit of an atom. So this is calculation. In this way, basically we calculate the radius of an atom in which radius of a shell in which electrons are present. So basically these values are discrete and basically indicate that every shell of an atom have a specific radius and they will have an assigned energy to the specific area or region of the radius. So in this way they will have the electron in an orbital shell will have a discrete amount of energy in a specific shell orbit. So now, dear student, let us calculate velocity of electron in an orbit. So velocity of electron in an orbit. Velocity of electron in orbit or shell. Since according to Bohr Atomic Model, angular momentum of an electron in an orbital is quantized and it is equal to mvr is equal to nh divided by 2 pi. Our angular momentum is equal to integral multiple of h divided by pi. Suppose that we say this as equation number A, and we know that as we have calculated radius of an orbit Rn is equal to n square h square epsilon naught divided by z e square pi m. Suppose this is equation number B. So now putting equation B in equation 1 in equation A, sorry. So we will get mv into r is the radius of an orbit which is equal to n square h square epsilon naught divided by z e square pi m is equal to nh divided by 2 pi. So now the student, n square will be cancelled with n, h square will be cancelled with h, okay, pi will be cancelled with pi, okay. So then we get velocity of an nth orbit Vn is equal to z e square divided by 2n h epsilon naught. So now as velocity of nth orbit is equal to electron in nth orbit is equal to z e square divided by 2 epsilon naught nh, as you know that the e square divided by 2 epsilon naught pi is constant. It has a constant value. So basically we can write this equation for nth shell as Vn is equal to z divided by n into e square divided by 2 pi epsilon naught. And say that this is equation number C. Student, we can from this equation number C, we can calculate a velocity of electron in different orbit. Suppose that we want to calculate velocity of electron in first orbit or shell. So value of n will be 1. So velocity of electron in first orbit will be z into e square divided by 2 pi epsilon naught. Similarly, velocity of electron in a second orbit or second shell will be v2 will be n, value of n is, this will be 2, so v2 will be z divided by 2 into e square divided by 2 pi epsilon naught. So in this way, from these calculations, from this equation basically, we can calculate the velocity of electrons in any orbit or in so in this way, dear student, we can also calculate kinetic energy of electrons in orbit or shells, in shell or in orbit. As you know that kinetic energy of electron, kinetic energy is equal to half mv square, mv square. Suppose this is equation number A, and as you know that we have calculated velocity for nth orbital and orbital of electron in n orbital is equal to z e square divided by 2 nh epsilon naught. Suppose this is equation number 2. So by putting equation number B, so by putting equation A in equation B, we can basically get that kinetic energy, kinetic energy is become equal to, kinetic energy is equal to half m into v square z e square divided by 2nh into epsilon naught square. So this equation will become kinetic energy is equal to, kinetic energy will be equal to, kinetic energy will be equal to 1 over 8 into n z square e4 divided by n square h square epsilon naught. So we will get that kinetic energy by simplifying this equation. We will get that kinetic energy is equal to z square divided by n square, since the rest are constant, so we will write them like this: me4 divided by 8 h square epsilon naught square. Since you know that the value of, we are calculating the value of me4, which are constant, and m is the mass of electron, e is the charge of electron, divided by 8 h square. H is a long constant, epsilon naught is also fixed value. So the total value become, by calculating this value of, become 13.6. So equation number D will become as kinetic energy of an electron in any or in nth orbit will be equal to 13.6 into z square divided by n square electron volts. So suppose this as equation number E. So basically from this equation number E, we can calculate kinetic energy of electron in a different orbits. So from this equation, we can calculate kinetic energy of electron in a first orbit, as kinetic energy in a first orbit will be equal to 13.6 into z square divided by 1 square in 1 square. So this will be the value of kinetic energy, and it will be in a form of electron volt in first energy level. Similarly, in a second energy level, the value of n will be 2, and we have to include value of n as a 2 in equation numbers E. On the basis of that, we will basically calculate the kinetic energy of electron in second energy level. So in this way, we can calculate kinetic energy of electron in different energy levels. This went on the basis of Bohr atomic model, the postulates of Bohr atomic model, we can calculate the potential energy of electrons in a different orbitals or shells. Since you know that potential energy of charge is usually electrostatic potential energy of a charge is usually it is equal to 1 over 4 pi epsilon naught Q1 Q2 divided by R, whereas Q1 is a charge on electron and it is E, and whereas Q2 is a charge of on a nucleus which is equal to ZE. So our potential energy between nucleus and electron will be 1 over 4 pi epsilon naught into z e square divided by r. Okay, so in case of calculating potential energy of nth orbit, as you know that radius of nth orbit is equal to Rn is equal to n square h square epsilon naught divided by z e square pi into m. So suppose this is equation number 1, and suppose this is equation number 2. So in case if we want to calculate a potential energy of nth orbit, so we can include or incorporate the value of Rn in equation number 1. So we will get basically potential energy is equal to 1 over 4 pi epsilon naught into z e square divided by putting the value of r nth or radius of nth orbit, which is equal to n square h square epsilon naught the divided by z e square pi into m. So now, student, since you know that the charges on the charge on a proton and nucleus is plus, and whereas the charge on electron is negative, so the potential there we will include a negative sign in equation of potential energy, and we will get equation of potential energy as minus 1 over 4 pi epsilon naught into z e square divided by n square h square epsilon naught divided by z e square pi into m. So by simplifying this equation, we will get that potential energy potential energy is equal to minus z square E4 m pi divided by 4 pi n square epsilon naught square into h square. Pi will cancel with pi. and we will get equation as potential energy PE is equal to minus Z square divided by N square into M 4 divided by 4 epsilon naught square into H square. So as you know that the m e square as you know that me4 divided by 4 epsilon naught square h are constant and their value is equal to 27.2. So the potential and energy value of potential energy will become minus 27.2 into z square divided by n square. So this, suppose that this is equation number 3. So from this equation number 3, we can calculate the potential energy of first orbit, second orbit, third orbit, and so on up to nth orbit. So basically, with this equation, we can calculate the radius of orbital or shell of any of shell present in any types of atom. So now, students, let us calculate total energy of electron present in a shell or in an orbit. So electron present in atom in orbit or shell have energy, and the total energy of electron T total energy T total of electron energy of electron will be equal to kinetic energy plus potential energy of the electron. So as we have calculated, kinetic energy of electron is equal to 13.6 into Z square divided by N square. Suppose this is equation number 1 and this is equation number 2. Similarly, potential energy of electron in any orbit or shell is equal to minus 27.2 into Z square divided by N square. So suppose this is equation number 3. So by putting equation 3, equation 2 and 3 in equation 1, we get total energy of an electron in an orbit is equal to 13.6 Z square N square plus, or we can write this as minus 27.2 into Z square divided by N square. So we get total energy as total energy is equal to minus 13.6 into Z square divided by N square. So this will be a total energy of electron in nth orbit or nth shell of an atom. So from this equation, suppose this is equation number 4. From this equation number 4, we can calculate total energy of electron in any shell or in any orbit. Suppose we want to calculate total energy of electron in first energy level. So for this, value of n for first energy level is 1. So total energy of electron in first energy level will become minus 13.6 into g square divided by 1. So similarly, total energy for electron for second energy level will be total energy Te will be equal to minus 13.6 into z square divided by n is the value of n is 2, so n square will be equal to 4. This will be total energy of electron in a second orbit or second shell. So dear student, in this way, from these first 5 postulates, we basically can calculate energy of electrons, total energy of electrons in a different orbital cell, kinetic energy of electron in different orbital cell, potential energy of electron in different orbit or cell, velocity of electron in different orbits or shell, and even we can calculate radius of different orbits or shells or energy levels in an atom. So now let's discuss the last and sixth postulate of Bohr atomic model. The sixth postulate of Bohr atomic model states that electron can gain and even lose energy. So this is quite tricky. Initially, if Bohr postulate said that electron cannot gain or lose energy in a fixed energy level. But here, this in sixth postulate, Bohr is saying that electron can gain and lose energy. How? If electrons are present in orbit or shell, then how they can gain or lose energy. Student, please keep in mind that in atom there are fixed energy levels or shells like K shell, L shell and M shells. All these shells have a specific particular amount of energy. An electron in these shell will have particular amount of energy, which means that energy of electron will remain stationary in particular shells. However, whenever electron gain energy from outside, then the energy of electron in a particular shell will increase. Due to this, electron can jump from lower energy shell to a higher energy shell. And similarly, electron can also absorb energy. Similarly, electron can also emit energy, sorry. So by emission of energy, electron can jump from higher energy to a lower energy level or shell. Though the energy of energy levels will be same, but electron are basically gaining energy from outside, or electron is basically losing energy. So due to this, they will jump from higher energy level to lower energy level, or they will jump from lower energy level to higher energy level, though the amount of energy levels will remain same. So now let us explain this with a schematic diagram. Since consider the example of a sodium atom. As you know that sodium atom has a nucleus, and in a nucleus there are 11 protons and as well as 12 neutrons. So the atomic number of sodium is 23. And around the sodium are three shells. First shell is nucleus is three shell. First shell is known as K shell, and K shell have 2 electrons. Similarly, second shell around the sodium atom is known as L shell, and this L shell has capacity of accommodating 8 electrons. So in sodium atom, L shell will basically have 8 electrons in it. So these dots basically represent electrons in a sodium atom. So these second shell, which is basically L shell, it has 8 electrons. Similarly, the third shell in a sodium atom is M shell. M shell, and M shell have 1 electrons in it. 1 electron. So now Dear student, please keep in mind that every shell, like K shell, have a particular amount of energy. Similarly, L shell will also have a particular amount of energy. Similarly, M shell will also have a particular amount of energy. So they have a specific amount of energy. So keep in mind that electron in K shells will have a same energy. And similarly, all electrons in L shells will have same energy. The energy of K shell electron will be different than the energy of electron present in L shell. But however, electron in same shell like L shell will have same energy. Similarly, electron in M shell will always have different energy than electron in L shell and in K shell. So every shell have electron, and electron in these shells have a discrete specific amount of energy. Then how electron can gain or lose energy when they are present in a shell? This can be done whenever electron gains some energy from outside. When electron gains, suppose this is an amount of energy, or suppose that this is a radiation which is basically which is falling on electron. So the radiation when fall on electron, then this radiation will cause increase in an amount of energy of electron. So when the electron energy is increased, so electron from this lower L energy level will jump into higher M energy level, like this. So in this way, electron will basically gain an energy. Okay, and by gaining energy, electron basically jump from this lower energy level, L energy level, into high energy level, which is M energy level. So basically, radiation, incident radiation, incident radiation with high energy. Incident radiation is basically radiation radiation caused the of excitation of electron, and excitation of electron result due to an absorption of energy from the incident radiation. So in this way, electron basically gain energy, and similarly in some cases electron can lose energy. Suppose that this electron at M shell loses its energy. Okay, so when electron loses energy, this electron will jump from N shell to lower energy level L shell, in case when electron loses energy. So in this way, the electron when loses its energy, electron will jump either from higher energy state to a lower energy state, or when it's gain energy, it may jump from lower energy state to higher energy state. So there will be excitation, and as well as there is a possibility of de-excitation of an electron in energy level. However, dear student, please keep in mind that though there could be excitation and de-excitation of electron between these energy levels, but the amount of energy electron gain or lose will be discrete, and it will be equal to amount of the electron present in different particular energy level. So this is all about Bohr atomic model. Bohr atomic model state that electron revolve around a nucleus in a fixed energy level. The amount of energy of electron in this fixed energy level is quantized. Angular momentum of electron is integral multiple of h divided by 2 pi. So, and furthermore, Bohr atomic model state that electrons in a particular orbit have a specific amount of energy and they can lose or gain energy, but even in that case, electron could jump from lower to high energy level or from higher to lower energy level, but in these particular cases amount of energy associated with energy level will remain same. So dear student, this is all about Bohr atomic model. So thank you for watching this lecture.